Hello and welcome back to the Stratford Public Schools Technology Department's Digital Learning Series, Tech Tuesday. Today, we are exploring Standard 1.5, the Computational Thinker. Often, when we hear computational thinking, we assume it means teaching kids to code. But that is a misconception. This standard isn't just about computer science. It is about a specific type of problem solving. It's about learning to speak the language of logic so that we can use computers to help us solve human problems. Here is our roadmap for the next 30 minutes. We will start with the big idea, the translation of messy thoughts into logical steps. Then, we will break down the standard into its 4 key indicators: defining, analyzing data, decomposing, and algorithmic thinking. For each step, Dr. Eckler will provide a live demonstration using the tools you already have: Google Docs and MagicSchool AI. The big idea behind the computational thinker is translation. Humans are messy. We say things like traffic is bad or the plant looks sad. Computers are precise. They need numbers, variables, and rules. Our job is to teach students how to translate their messy, abstract observations into structured data that a computer can understand. Once they make that translation, they can harness the power of technology to solve the problem. The Connecticut Digital Learning Standard states, students develop and employ strategies for understanding and solving problems in ways that leverage the power of technological methods. Notice it says, leverage technological methods, not just write code. This means using data analysis, models, and algorithms to find answers. Let's look at the first step, defining the problem. We begin with 1.5a, problem definitions. A computer cannot solve "the cafeteria is too loud." That is an opinion. To use technology, a student must reframe that statement into something measurable. They need to define the variables. We have to teach the students a new way of seeing the world. We call this escaping the adjective trap. Students naturally speak in feelings. The lunch line is slow. The room is hot. The test was hard. But a computer doesn't know what hard means. To a computer, those are just errors. To teach Standard 1.5, you must force students to stop acting like critics and start acting like sensors. They have to swap the adjective slow for a measurable variable time. Until they do that, they aren't doing computational thinking. They're just complaining. So, how do you teach this tomorrow? You play a game called the robot test. When a student comes to you and says, "My plant looks sad," don't just give them water. Pause. Pretend to be a robot. Say, error, does not compute, define sad. Force them to translate. They might struggle for a second, but eventually they will say, "The leaves are drooping," or "The soil is dry." Now you have data. Droop angle is a variable. Moisture level is a variable. Once they pass the robot test, then they are allowed to open the Google Doc and start solving. Now that the problem is defined, we need to collect and analyze the info. This is 1.5b, data sets. Students often collect data but stare blankly at the numbers. We need to show them how to use tools to reveal the story hidden inside that data. Once the students have collected their data, maybe they counted cars or measured plant growth, they usually hit a wall. We call this data blindness. They look at a spreadsheet full of numbers, and their eyes glaze over. To a 5th grader, a spreadsheet just looks like a math test. They can't see the trend because they are too busy reading the individual digits. To teach Standard 1.5b, we have to stop asking them to read the data and teach them to visualize it. We need to turn that wall of text into a picture. So, how do we fix data blindness without teaching complex statistics? We use a tool I call the digital highlighter. In Google Sheets, this is called conditional formatting. Think of it like giving the computer a highlighter pen and saying, "Hey, color every number over 50 in bright red." Suddenly, the student doesn't have to hunt for the answer. The answer lights up. This shifts the cognitive load from finding the data to interpreting the problem. We know what the problem is and when it happens. Now we need to solve it. But solving big problems can sometimes be too big. This brings us to 1.5.c, decomposition. This is the skill of breaking a complex system down into manageable parts. We've analyzed the data. Now we need a plan. This brings us to 1.5.c, decomposition. The biggest enemy of innovation in the classroom is project paralysis. You assign a big, exciting project like design a sustainable garden, and half the class freezes. They don't know where to start because they are looking at the whole mountain at once. To teach decomposition, we have to stop grading the garden and start grading the steps. We need to teach them that a big problem is just 20 small problems stuck together. In a professional kitchen, a chef doesn't just start cooking. They do mise en place. They chop and organize every ingredient first. Decomposition is mise en place for the brain. But here is the catch. Novices don't know what the ingredients are. They've never built a garden before, so they don't know they need a soil test. This is where we use AI not to do the work, but to structure it. We use MagicSchool AI as the sous chef to list the ingredients, so the student can get to cooking. Finally, 1.5D, algorithmic thinking. This is the solution phase. An algorithm is simply a sequence of steps. If this happens, then do that. We want students to design these logical flows to test their solutions. You don't need to learn Python or any coding skills to do this. Now we've reached the solution phase, algorithmic thinking. Kids today are digital natives, but that often just means they are good at swiping. They treat apps like magic black boxes. They press a button, and food arrives. To teach standard 1.5D, we have to pry open that black box. We have to teach them that magic is just a series of very small, very specific instructions. An algorithm is just a recipe that handles choices. You don't need to teach Python to teach algorithms. You just need to teach if this, then that. Life is full of algorithms. If it is raining, then take an umbrella. If the light is red, then stop. We are going to use the space in our Google Doc to help us write these statements with a template. Now, Dr. Eckler is going to model the entire process for us using a single Google Doc and one amazing MagicSchool tool, the assignment scaffolder. Thank you, Dr. Eckler.
Before I dive into the demo, I want to bust this myth that computational thinking is just for the computer lab. Computational thinking is the skill of turning a feeling or an idea into a formula. It happens in every single room of every single school building all the time. In math, it's not just about solving for X, it's analyzing error patterns. I keep getting questions wrong because I am miscalculating the negative signs in 3 out of 5 problems. In science, it's debugging an experiment. My plant died becomes the moisture in the soil dropped below 20% for 3 consecutive days. In social studies, it's analyzing cause and effect. The revolution happened because people were angry. Becomes the price of bread rose 400% in 6 months, triggering a specific algorithmic threshold for civil unrest. In English, it's debugging an essay. My flow is choppy. Becomes my average sentence length is only 5 words and I need to increase variety. In world language, it's pattern recognition. Spanish verbs are confusing. Becomes I am failing to apply the AR ending rule in the past tense. And yes, it even happens in your elective classes. In art, it's decomposing a masterpiece into layers. In music, it's analyzing why a minor key sounds sad. In culinary classes, it's optimizing a ratio for a recipe. In physical education, it's tracking split times to improve performance. Every one of these examples can move a student from I don't get it to I have a solvable problem. That's the concept of computational thinking. And I am going to now show you how this computational thinking project workspace on your screen is a template that you can use in any subject to help bring your students from I don't get it to I have a solvable problem. So now to make this easy for you, like I said, this is a singular document and it works in any subject, no matter what you're doing. Now, many of you know that prior to going into technology, I was a high school English teacher. So that's my first love. And that's what I'm going to go back to walk you through how you would use this particular document to help your students. So the first thing a student has to do is solve a problem. So let me set the stage for you. A student comes to you and says, my essay is messy. So I'm going to add that here. My essay is messy. Now let's think about that. That's a feeling. A computer can't fix messy. But that's where this first step in the process comes in, the translator. And the idea here is that we are going to force our student to translate that feeling into a measurable variable. So you ask the student, what do you mean by my essay is messy? Make them think about it. And remember, here is where you want to have productive struggle. Make them figure out why it's messy. And so maybe the student says, my paragraphs don't have clear topic sentences. Now we have a solvable problem. It's not just messy, which is an arbitrary kind of generic terminology. We now know that this essay is missing components. Now the next step is to decompose the problem. Big problems are just a bunch of little problems put together. So how are we going to fix it? Novice writers don't always know the steps to help them fix that. So that's where we're going to bring in a little bit of AI here to help our students. Now, I'm going to use the teacher side of this just because we haven't opened up Magic Student yet, but you can actually use this exact same tool for your students and assign it to them to use in this situation. So I'm going to use the assignment scaffolder. And I am going to actually tell it, in this case, I'm a student. Your students wouldn't have to say they're students if they're using the student side of the assignment scaffolder. But I am asking MagicSchool, I am a student. My problem is my paragraphs lack topic sentences. Break the solution down into 4 specific steps I can follow to fix this. So now you're not actually saying, add the topic sentences in for me. You're asking MagicSchool to give the student directions as to how they can fix that. So let's see what MagicSchool comes up with. Now this is incredibly long. However, you're looking at the 4 steps. This is something that the student would get in the output, but they're just going to copy these steps here. So read your paragraph and find the main idea. We're going to put that in here. Okay, you go back. Step 2, turn your main idea into a clear topic sentence. We'll add that one in. Step 3, make sure the rest of the paragraph supports your topic sentence. And then step 4, add a linking word or phrase to check for clarity. Okay, and you'll notice that when students use the assignment scaffolder, it'll actually give them even more information here. For the purposes of brevity, I'm not going to copy all of that in, but a student could very easily copy and paste this entire thing by just clicking this little copy message. And if you really wanted to, instead of having the steps broken down in a box, you could change this up a little bit, and then the student can just paste it right in there. And then here, it will also work with the student to provide them like step-by-step directions in there to do this work and give them a suggested revision. You don't have to go that direction, and actually eventually you might be able to modify this assignment scaffolder here and change it up a bit so that it doesn't give them any suggested revisions. But either way, they've now taken this information that they need to do to fix this problem and broken it down into steps. Now, the third part of this is their data detective phase. This is where they're going to verify the problem using some sort of data. Now, you could get super fancy with a spreadsheet, and if you're working in a class where you really want students working on spreadsheets, you can use conditional formatting. But here, I'm just looking at something that is going to make things easy for the students. And what I want them to do is I want them to look for the variable A is their topic sentence. And If there is a topic sentence, they will highlight it in green. And if there is no topic sentence, they're going to highlight in red. And here, the countermeasure is where they would go through and count how many times. So let's say it's a 7-paragraph writing assignment that they did. They have an introduction and a conclusion, so it's actually 5 paragraphs within the body. And let's say 2 of them have topic sentences and 3 of them do not. And then they can actually take notes here to say where they're missing. So let's say here they might say, the middle of my essay is bright red, so that's where I might be losing focus in my essay. So this is requiring the students to actually go in and look at their own data from the work that they're doing. Now, the last part of this process is actually building the algorithm. So it's automating the solution for next time. And the goal for this is that we want to create a rule for the students so it doesn't happen again. We want them to learn from this process. So what we're going to do is create an if then else statement. So if the data shows, and in this case it's if I finish writing a paragraph, then I will highlight the first sentence to check if it summarizes the main points. And then else, if it does not summarize it, I must stop and rewrite that sentence before starting the next paragraph. So that's the alternate action. So if the data, then what I'll do, else, otherwise. So now we have a complete algorithm. It gives students a specific procedure to follow. Check, verify, and then if it doesn't work, fix. And now they're successfully computing a better essay. Now, as you're thinking of other subject areas, for example, you might have a fuzzy problem in social studies like the revolution was inevitable. So if a student were to take that and break it down and decompose it, they might have a definition that there were 3 documented tax increases in the 5 years prior to the war. And so then they can use MagicSchool to help them decompose what happened and then write an algorithm to understand the concept. You can do the same thing in pretty much any subject area. Using the computational thinking process is not limited to math and not limited to technology situations. It's a way to make students think more clearly and more concisely about a problem and then develop a solution to that problem. And we all know that many of our students do need to be able to do this. They need that productive struggle, and that's where the learning happens. That's how we take our tier 1 instruction to the next level and find that sweet spot in instruction.
Thank you, Dr. Eckler, for providing us with a variety of options for using the computational thinking process with students. You don't need to be a coder to teach this. You just need to help students translate feelings into facts, decompose big tasks with AI, visualize their data, create rules for success. All the materials for today's session are available for SPS educators right now in the Tech Department Google Classroom. We have included the customizable Computational Thinking Workspace, Google Doc, which works for any subject. A cheat sheet of translation prompts to help you turn fuzzy feelings into measurable facts in English, science, and math. A guide to using the MagicSchool assignment scaffolder to help students decompose big projects. Thank you for joining us for Tech Tuesday. We look forward to seeing how you turn your students into logical architects. See you at our next session.